Hello, and welcome back to New Scientist Weekly, your curated selection of the week's science stories. I'm Timothy Revel in New York.
And I'm Christy Taylor, also in New York. This week on the pod, how fungi in soil grow faster when you play sounds at it, how to grow chickpeas on the moon, and some new data on how people are being affected in U.S. states with near-total abortion bans.
And why owls may be even better at turning their heads than we thought. But first, the machines are coming for your jobs. That's a common refrain from some tech CEOs and Silicon Valley leaders. But a new study suggests that they may not be coming quite so quickly as we thought. Some AI technologies are currently just too expensive for most businesses to immediately adopt. Technology reporter Jeremy Su is here with more. Hi, Jeremy.
Hello.
So we've seen many reports and predictions about how many jobs AI might take. What makes this particular report stand out?
Well, most previous studies focused on what AI has the technical capability to do. But this time, a team that included MIT's Computer Science and Artificial Intelligence Lab calculated whether it's actually cost-effective for businesses to use AI for automating human work.
And here we're talking about a particular kind of AI, right? Computer vision, which is where image recognition algorithms attempt to look at a scene and figure out what's happening.
Yeah, exactly. The researchers identified about 400 vision tasks across U.S. job categories that could potentially be automated by AI computer vision. So we're talking about retail store supervisors, for example, visually checking price tags on items, or nurse anesthesiologists watching over unconscious patients during surgery by looking for dilated pupils or changes in cheek color.
I feel like we should point out that these kinds of vision tasks do make up just a small part of most people's jobs. So a nurse anesthesiologist does a lot more than just visually monitor patients. So it sounds like even if it's a large number of tasks in total that AI could automate, the proportion of tasks per job is actually pretty small.
Yeah, exactly. And that's why the researchers calculated how automation of vision tasks might impact workers' salaries and benefits instead of trying to predict the number of jobs lost.
How concerned should we be then about employers using AI computer vision to chip away, bit by bit at humans doing work?
Well, in this case, the study found that just 8% of all U.S. non-farm businesses have a task that could be cost-effective to automate using this type of AI. That means just 0.4% of U.S. worker compensation would be affected. And even the very biggest companies could only cost-effectively automate less than 10% of their vision tasks.
So it's fair to say that this initial wave of automation through AI might be more gradual and less of a shock.
For sure, that seems to be the case for at least AI computer vision, but there are many other types of AI that can impact human workers. Another study has shown that AI based on large language models, such as ChatGPT, is already reducing the available jobs and earnings for human freelance workers.
And even for these computer vision tasks, they might be too expensive now to automate, but that's likely to change in the future, right?
Most likely. There are definitely many researchers and companies working to make AI capabilities cheaper to deploy, and some Silicon Valley startups are also betting that they can provide these AI technologies more cheaply if they can get enough customers. But the same people are also grappling with the growing financial and environmental costs of AI development. So it's hard to predict exactly when AI technologies might get cheap enough to displace a lot more human workers.
We've all heard about those gardeners who swear that talking or singing to their tomato plants makes them thrive. But this week, our reporter in Australia, James Woodford, wrote about new research which has found you can play sounds to fungus, and they do, in fact, grow faster. Hey there, James.
Hi, Christy. Thanks for having me. Yes, every now and then you see some research that really makes you wonder if it's a prank, but I can assure you it's not.
I was definitely going to ask. So tell us about this new study.
Well, this research was a pilot study led by Jake Robinson from Flinders University in South Australia, and it has two parts. Firstly, the team built a soundproof box, and inside the box, they placed tea bags buried in soil in the pots. And for the connoisseurs out there, half the tea bags were green tea and half were rooibos tea. They played sound with a frequency of 8 kilohertz and a volume of either 70 or 80 decibels for 8 hours per day for 14 days. And I have to say, I'm really glad I wasn't a teabag in having to listen to that. And for reference, 8 kilohertz is a pretty high-pitched, piercing tone. I'd recommend looking it up online and not having your headphones too loud. A control group of teabags received just the background noise that was within the soundproof box, and that was less than 30 decibels.
Yeah, okay, so for this experiment group, 80 decibels of a high-pitched tone for 2 weeks. 80 decibels is like listening to a vacuum cleaner. So I'm guessing the teabags asked for some peace and quiet at the end?
Yes, I would definitely be asking for some peace and quiet. But no, actually something really interesting happened. The fungi that were naturally in the soil, in the pots where the teabags were buried, grew much faster when they were exposed to sound. After 14 days, those teabags, given the noise treatment, actually weighed 3.1 grams compared to the original weight of the teabags of 2.5 grams, whereas those given the silent treatment weighed almost the same as they had before. In other words, the fungus compost in the teabags had grown so much over the fortnight that they had, on average, added more than 0.5 gram to the teabags.
That's already such a wild result. But James, you said there was a second experiment?
Yes, there was. In the second part, the scientists played a monotone soundscape of 80 decibels at 8 kilohertz to Petri dishes containing the Trichoderma harzianum, a fungus that grows in soil and promotes plant growth. And after 5 days, the samples exposed to sound had an average of 2.5 million spore cells per milliliter in the culture medium, nearly 5 times more than the control samples.
That's amazing. So this is more evidence then that fungi are growing and reproducing in response to this sound. What do they think is going on?
And this is the part where it gets really strange, because the short answer is, no one is exactly sure. But Jake Robinson explained to me that just as forests and the ocean have a soundscape, and, we're all familiar with whale songs and the cracking and clicking of crabs and things, but so too do underground environments. And these sounds, mostly produced by creatures living in soil like ants and worms, can help indicate whether soils are healthy or degraded. But what hasn't been known until now is the impact that sound has on the fungi living in dirt. And what the team is hoping to do next is start to see whether sound could help speed up the restoration of degraded areas. They would also like to have a better understanding of what is the mechanism that leads to the growth. And one way to help understand it is that Jake told me to think of sound as being like an energy input, which somehow the fungi are turning into growth. This may be via a so-called piezoelectric effect, where mechanical pressure, like that produced by sound waves, is converted into electrical energy that somehow feeds fungal growth.
Got it. So one day our compost bins may maybe produce sound to speed up the decomposition of our vegetable scraps?
It's funny you ask that, because I actually put that exact scenario to Jake, and he agreed that that was one possible application, but there's a lot more work to be done first.
One of our favourite things about being science journalists is learning things that we can then excitedly tell you, our listeners. And nothing is more emblematic of that than the Escape Pod. That's our delightful, news-free celebration of how the world works. And the latest episode is all things music, how birds can play jazz, the music hiding in scientific data, and possibly the biggest question of all, why do we humans love music so much? That's there in the feed for you to listen to, right after you finish listening to the weekly, of course.
Definitely do that first. And coming up next Tuesday, it's Culture Lab. TV columnist Bethan Ackerley is in conversation with the explorer and documentary maker Simon Reeve. Hear all about his new series, Wilderness, the wonder of our planet's most dramatic landscapes, and conservation lessons from his many travels.
It was dark, the wind was howling, and the mountain range of the Andes was just there in front of me. And I'm standing there holding my little roll of biodegradable toilet paper and taking it all in. I won't forget it.
That's coming up on Tuesday.
And one more thing, we've got a special offer on digital subscriptions for podcast listeners at the moment. For just £1 or $1 per week, you can gain full access to our articles, both present and past. Just go over to newscientist.com/podcasts to get started.
Earlier this week marked the 50th anniversary of Roe v. Wade, the landmark U.S. Supreme Court decision that protected the right to an abortion. That decision was overturned more than a year and a half ago, prompting a wave of new abortion restrictions in the country. This includes some states that now have total bans, meaning no exceptions for pregnancies that occur as a result of rape. Now, it's not new that there may be people seeking abortions because their pregnancy is the result of a sexual assault, and who now can't access abortion care. But new research now tries to tally just how many people this might be, and found that number may be in the tens of thousands. Our reporter Grace Wade is here to discuss these findings. Hey, Grace.
Hi.
So, Grace, could you explain these estimates and how they were calculated?
So researchers estimate that there were almost 65,000 pregnancies resulting from rape in the 14 U.S. states that banned nearly all abortions after Roe v. Wade was overturned in 2022. Because sexual assault is so stigmatized, you can imagine it's really hard to track incidences of rape. So the researchers used the most recent data on rape incidents in the U.S., which was collected between 2016 and 2017. They use that to roughly gauge the proportion of rapes that result in pregnancy across the country each year. They then used law enforcement data to estimate the number of rape-related pregnancies in each state after abortion bans were enacted.
And 65,000, you said. That's a huge number. And you said that was in 14 states with total or near total bans. So what does that mean exactly?
So to put that into context, about 80 million people live across those 14 states, which includes Texas and Georgia. That's almost a quarter of the U.S.'s population, and total or near total abortion bans mean that in almost any scenario, abortion is illegal. In theory, all of these states allow exceptions for medical emergencies, and 5 of them also have exceptions for rape, but in practice, that's really not the case.
What does that mean? Why not really the case?
Well, it's still very difficult to get an abortion even if someone qualifies for one. That's because the majority of abortion providers in these states have either closed down or moved elsewhere. So even if abortion is permitted in cases of rape, people don't really have anywhere to get the procedure. And if they do, they usually have to report the assault to law enforcement, and we know the majority of sexual assaults go unreported.
Do we have any idea how many legal abortions happen in those 5 out of the 14 states that have exceptions for rape?
Fewer than a dozen abortions per month. So that means almost everyone who became pregnant as a result of rape did not receive a legal abortion in those states. And the same is, of course, also true for those in states without exceptions for rape. And that's about 90% of the estimated 65,000 rape-related pregnancies. We also know from previous research that people denied an abortion have worse outcomes than those who aren't. They are more likely to stay with abusive partners, live in poverty, and have worse physical and mental health. And that's for anyone denied an abortion. Those consequences are probably even more pronounced for those people who become pregnant as a result of rape.
Such an important story. Thank you so much, Grace.
Thank you.
Next up, we've got a big win for fans of space travel and hummus. Researchers have managed to grow chickpeas in moon dust for the first time ever. Space reporter Leah Crane worked on this story for us and is here to talk all about it. Hi, Leah.
Hello.
All right, first off, can you talk us through why is it so hard to grow stuff on the moon? Is it because it's made of cheese?
If only, then we wouldn't need to grow stuff. But there are a whole bunch of reasons. For starters, there's no nutrients in moon dust and a bunch of heavy metals, which is obviously bad for plants. If you plant something in pure lunar regolith, which is just another word for moon dirt, it'll die pretty much right away. The texture of moon dust is also really different from soil on Earth. It's this pointy, clumpy, awful mess. So it can clump together and make it impossible for water and air to get through to the roots of a plant.
Yeah, I know this isn't the first time we've tried growing stuff in moon dirt. I remember a study from a year or two ago where they grew a mustard relative. But this seems cooler and tastier to me.
Yeah, personally, I do think it's cooler, in part because chickpea plants are just a lot bigger than mustard greens. And chickpeas are also more nutritionally dense, which makes them sort of more useful. But the other part is that this work took sort of a holistic approach. The researchers didn't just chuck the seeds into some moon dust. They added some fungus and worms to sort of help it grow. And the fungus is there to sequester all those heavy metals so they don't kill the plants. And the worms are there to compost things that would otherwise be garbage and turn them into nutrients. So over time and many generations of plants, that whole process could essentially fix its own ecosystem and make the moon dust fertile.
So how well did the chickpeas do? Did they love it?
I wouldn't say they loved it. In all the experiments like this, they use a synthetic moon dust and they mix it with other stuff so the plants don't immediately die. In this case, they mixed it with worm droppings, which is called vermicompost, in different proportions, sort of lots of moon dust, less moon dust, and it totally worked. Even in a mixture that was up to 75% moon dust, the chickpeas grew and flowered, and the researchers harvested them. The plants, of course, weren't as healthy as chickpeas grown in regular earth soil, but they did extraordinarily well for moon plants.
All right. Like Tim, I love a tasty chickpea, and I'm sure he's wondering this too. Can we eat these moon chickpeas?
Well, we don't know yet. Of course, that was one of the first things I asked the researchers if they ate them. They did not. But they did harvest them, and they're planning to send them out to get tested for things like, of course, heavy metals to make sure that they're edible. When I talked to them, they seemed pretty confident that even if this first generation of chickpeas isn't edible, ones grown after the fungus has had more time to absorb more toxins probably will be.
Delicious. What's the next challenge for growing food off Earth?
I think it's interesting to really think about whole ecosystems rather than individual plants, just because that's what we'll need to do if we ever want any significant amount of greenery on another world, which personally, I think if we're going to go there, that would be nice. So there are a bunch of different directions that this research is going now, from what organisms to add to the soil to make the plants grow better, to what different plants we should try, to things as simple as how to water plants without gravity, because gravity is really important for directing water to the roots. And it's all really fascinating, but the idea of a true space garden is still pretty far away.
All right, Tim, you like birds. Let's do a pop quiz. True or false? Owls can turn their heads all the way around 360 degrees.
I feel like you're trying to trip me up here, but that's a classic falsehood. Even though you sometimes see an owl turning their heads 360 degrees in a cartoon, what we normally see is that owls can do a maximum of 270 degrees, so about 3/4 of the way round. But I think you're about to tell me that that is in fact wrong.
It is possibly wrong, yes. Researchers may have found evidence that owls can actually turn their heads all the way around 360 degrees.
Unbelievable. Tell me how.
Right. So the catch is we have a team of researchers and they only studied dead owls, so other scientists are still a bit skeptical. But for this research, the team CT scanned the owls as the team then was rotating their necks. And what they found was that there appear to be no reasons why owls could not turn their necks all the way around. So we may not have seen it, but it appears to be possible.
I see. I guess absence of evidence is not exactly evidence of absence, but interesting nonetheless. Did they figure out how owls are so flexible in the first place? I mean, even turning your head 270 degrees is pretty impressive.
Yeah, that's one of the really cool things from this research. They were able to get some insights into how owls actually do it, and it turns out there are two different processes. First, owls rotate some of the joints between the bones in their necks, which already gets them an impressive 126 degrees around. But then they kind of just coil their entire spines like a spiral staircase. And doing that, they can get to 360 degrees. And even though this severely contorts the owl's spine, the researchers were able to manipulate the dead owls into that full turn without doing any damage to bones, muscles, or ligaments. So these poor dead owls were very well treated, even though, this kind of manipulation was happening. But again, since this has never been observed in live owls, the next trick would be convincing some live owls to show us that they can do it.
Maybe they're just keeping this secret from us.
They are not, in fact, what they seem.
Yeah, nice Twin Peaks reference there. Keeping it current as always. Another thing that happened this week is we got an update on attempts to build a robot avatar that can touch and explore things on your behalf and let you still feel what it's doing.
So if I want to get a hug from someone I can't visit in person, for example?
Yeah, exactly. A sort of hug bot, if you will. It's essentially a 1.2 meter tall humanoid robot called iCub3, and it's covered in lots of sensors and bendable joints, and at 2 recent robotics competitions, it was capable of walking around and doing physical tasks that mirrored the movement of a human operator who was 300 kilometers away, which is around 200 miles. And the human operator was wearing virtual reality gear, so they had a headset and gloves with haptic feedback, which all meant that they could experience everything the robot saw and touched.
Yeah, I could definitely see a lot of uses for something like this in allowing people to go places it's really hard to travel to or that just aren't accessible to them for other reasons. So how soon can I get my own?
There are a few snags still, unfortunately, which will stop you from getting on too soon. The team behind iCub3 say there's still a bit of a time lag, about 100 milliseconds between what the operator does and when the robot reacts, and that's called latency. So that can be solved if you just move a bit more slowly. But another more difficult thing is that the robot is really fragile. The team say that if it fell over, it would easily be damaged, and they're not sure it could actually get back up again on its own.
Oh no, the poor thing.
It'd be quite a frustrating experience to be controlling a robot writhing around on the floor.
Oh, I'm just thinking of like turtles stuck on their backs now. It does seem like you would want a bit more robust avatar before you started trying to send them out into the world for sure.
Absolutely.
All right, Tim, I've been really excited to talk about this next one. I wrote a story for the magazine this week about how a species of bacteria that might normally be prey for other bacteria turns the tables when the temperatures they're grown in get just a bit cooler. I'm talking about the difference between 32 and 22 Celsius, or about 90 and 70 degrees Fahrenheit.
The hunted become the hunters. Love it. Tell me who, what, how, when, why?
Well, we don't know why, but we do know when and how. The prey in question, our protagonist, is a species called Pseudomonas fluorescens, and we're putting it up against a well-known predatory bacteria that swarms around and uses chemicals to break other microbes apart. They're very tough. And so when our hero, Pseudomonas, is grown at 32 degrees Celsius, it stands no chance. It is dinner. But when you grow Pseudomonas at 22 degrees, bam! Introduce it to this same predator, and Pseudomonas, and I am quoting the scientific paper right now, slaughtered it to extinction. There was none left. And they also found that Pseudomonas had started secreting a chemical at the cooler temperature that degraded and destroyed these other microbes.
This seems very reminiscent of when people who grew up in colder climates think they're a lot tougher than everyone else.
I don't say that.
Yeah, for example, people who grew up in the Midwest. How did they figure this out in the first place?
Yeah, it was kind of a lab accident, actually, as all the best stories are. The original plan was to study that one swarming predator species I mentioned, and they were supposed to just grow a bunch of, easy dinner prey in a warm incubator. But then the incubator was full, so they left some of the Pseudomonas out at room temperature, which was pretty close to 22 Celsius, and then discovered the new superpowers later when they were running the planned experiment. And while this wasn't something they expected to find, they do think it's another piece of evidence that bacterial communities are extremely complex, and their food webs could be much more fluid than what we see, say, in animals. On top of that, there just may be more bacterial relationships that involve eating each other than we thought.
That's it for this week. Thanks so much for listening. You can find all the stories we talked about today in the show notes, and you could subscribe to this podcast on whichever app you're currently listening on.
Plus, if you like the great stories we're bringing you, please give us a rating or review on Spotify and Apple Podcasts. It really helps us get into more people's ears, but not in a weird way. We'll be back next week. Bye for now.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.